Imagine a lone traveler, Voyager 2, drifting silently through the endless dark, far from the warmth of any sun, a tiny spark of human curiosity on a journey no other machine has ever taken. Launched in 1977, when the world was a different place, when disco filled the airwaves and the first personal computers were just appearing, Voyager 2 began its odyssey from a planet still dreaming of the stars. This small, robust machine was sent on a grand tour of our cosmic neighborhood, flying past the giant planets, Jupiter, Saturn, Uranus, and Neptune, capturing breathtaking images and data that transformed our understanding of the solar system. For over 4 decades, it sent back postcards from the void, powered by the slow decay of plutonium, its heart beating faintly in the cold, sending whispers of discovery across the vastness. Now, after more than 45 years, Voyager 2 has crossed the final frontier of our solar system, venturing into a realm where the sun is just another distant star. It's pushed through the invisible boundary, the heliopause, that separates the sun's domain from the vast, uncharted territory of interstellar space, a place no human-made object has ever explored before. A piece of human engineering, built with less computing power than your phone, is now sailing among the stars, carrying our hopes, questions, and a bit of our story into the unknown. It carries a golden record, a message in a bottle for any civilization that might find it, etched with music, greetings, and images from Earth, a time capsule of who we were. As of August 2025, Voyager 2 is over 13 billion miles away. A signal takes nearly a day to reach it, and another to return. It is so far that Earth is just a pale blue dot, barely visible in the darkness. The engineers who built it have moved on, but a new generation listens for its faint signals, straining to catch every bit of data from this distant explorer. Just when we thought Voyager's greatest achievements were behind it, it sent back news that electrified science, reminding us that the universe still holds surprises. It found something monumental at the edge of our solar system, a discovery that challenges what we thought we knew about the boundary between our sun and the galaxy beyond. Voyager 2 has encountered a region of unimaginable energy, a seething boundary of superheated plasma, dramatically nicknamed the Wall of Fire. Here, at the edge of forever, our lonely sentinel continues its watch, sending back secrets from the darkness between the stars. To understand the Wall of Fire, we must first understand the heliopause, the invisible, dynamic boundary Voyager 2 crossed. This boundary is not just a simple line, but a complex and ever-changing frontier. Our sun constantly exhales a stream of charged particles called the solar wind, creating a massive bubble around our solar system, the heliosphere. This bubble is like a protective shield, enveloping all the planets and objects within our solar system. This bubble shields us from harsh cosmic radiation, deflecting most high-energy rays from the galaxy. Without this shield, life on Earth would be exposed to dangerous levels of radiation, making our planet far less hospitable. The heliopause is where the sun's wind meets the interstellar medium, the wind from other stars. This boundary is a fascinating region where the influence of our sun ends and the vastness of interstellar space begins. Here, 2 cosmic forces collide in a dramatic confrontation. The solar wind and the interstellar wind push against each other, creating a turbulent and dynamic region. For decades, scientists could only theorize about this boundary. It was a topic of much speculation and debate, with many questions left unanswered. Voyager 2 and its twin Voyager 1 have now given us a front-row seat. These spacecraft have traveled farther than any other human-made objects, providing invaluable data. The boundary isn't static. It breathes, expanding and contracting with the sun's activity. This dynamic nature makes it a constantly evolving frontier, full of surprises. Voyager 2's journey has provided direct measurements, turning theory into data. These measurements have revolutionized our understanding of the heliopause. Before Voyager, we imagined a smooth transition. Reality is far more dramatic. The data reveals a chaotic and energetic boundary, far different from our initial expectations. It's not a gentle handshake, but a violent, energetic clash. This clash creates a region of intense activity, where particles and magnetic fields interact in complex ways. This region is a natural laboratory for plasma physics, impossible to replicate on Earth. The conditions here provide unique opportunities to study the behavior of charged particles and magnetic fields. Voyager 2 is our eyes and ears in this extraordinary place. Its journey continues to provide us with insights that deepen our understanding of the universe. As Voyager 2 crossed the heliopause, the invisible boundary where the sun's influence ends and interstellar space begins, its instruments registered something astonishing. Suddenly, the spacecraft detected a colossal spike in plasma temperature, a reading so unexpected that it left mission scientists in awe. Temperatures soared to between 30 and 50,000 Kelvin, hotter than the very surface of the sun itself. This was not a gentle transition, but a dramatic leap into a realm of extreme heat. This wall of fire is not a fleeting phenomenon. It's a persistent, powerful feature, confirmed by both Voyager probes as they ventured into the unknown. Imagine flying through the coldest, darkest reaches of space, only to suddenly enter a region hotter than any furnace on Earth. The contrast is almost unimaginable. The discovery defied all expectations. Scientists had anticipated a temperature drop as the probe left the sun's protective bubble, not a fiery spike that seemed to contradict everything they thought they knew. Voyager's plasma science experiment recorded a sharp, unmistakable increase in the kinetic energy of the plasma, revealing a turbulent and energetic frontier. The probe was flying through a sea of incredibly fast-moving ions and electrons, each particle carrying immense energy as it rushed past the spacecraft. This finding confirms some theories about shock waves and turbulent boundaries in space, but it also raises new, profound questions about the nature of our solar system's edge. What mysterious forces heat this plasma so far from the sun? Could there be unknown processes at work in the interstellar medium? The wall of fire is just a metaphor, but it perfectly captures the shock and wonder of this discovery. A blazing threshold at the edge of our solar system, the heliopause is now seen as a dynamic, energetic structure, a place of immense power and constant change, not a static boundary. Voyager 2 didn't just pass a landmark, it flew through a cosmic crucible, fundamentally changing our understanding of the solar system and our place in the galaxy. If this region is so hot, why didn't Voyager 2 melt? The answer lies in the difference between temperature and heat. Temperature measures how fast particles move. The wall of fire's particles are incredibly energetic. But heat is about energy transfer. Particles must collide with something to transfer heat. The plasma at the heliopause is extremely thin, a near-perfect vacuum. There are so few particles that they rarely collide with anything. Think of it like putting your hand in a hot oven. The air is hot but not dense, so you don't burn instantly. The wall of fire is like that air but taken to an extreme. The total heat transferred to Voyager 2 was negligible. Its systems were never in danger of overheating. In interstellar space, high temperature doesn't mean intense heat. The wall of fire is hot, but it doesn't burn. Voyager 2's survival is a testament to both physics and engineering. Built in the 1970s, the probe was designed to withstand radiation and deep space cold. Its electronics are shielded, its systems redundant. The key to survival was the plasma's low density. Few particles actually struck the spacecraft. The energy deposited was minuscule. Voyager's temperature remained stable. Its instruments were designed to measure this environment, not just survive it. They studied and sent back data on the wall of fire. This feat highlights a crucial lesson. Space is counterintuitive, and careful engineering can overcome even the most extreme environments. Voyager 2's safe passage is a quiet triumph of science and engineering. The wall of fire wasn't the only surprise for Voyager 2. Its magnetometer found that the magnetic field just outside the heliopause is almost perfectly parallel to the field inside. Instead of a sharp boundary, there's a smooth, interconnected magnetic highway from our solar system into the galaxy. This suggests the boundary is more porous and interconnected than anyone imagined. One theory, magnetic reconnection, where tangled field lines snap and release energy, could explain the wall of fire's heat. This means our solar system is magnetically connected to the Milky Way. There's a physical link, influencing how cosmic rays enter and solar particles escape. The cosmos is more integrated and dynamic than we ever thought. The Voyager story is also about engineering miracles on Earth. In 2025, Voyager 1 faced a crisis. Its backup thrusters were failing, threatening to end the mission. The primary thrusters had been dormant for 20 years. NASA engineers, led by Suzanne Dodd and Todd Barber, devised a daring plan. Send a command to reset a power switch, hoping the thrusters would revive. The signal would take nearly 2 days for a round trip. With the only suitable antenna about to go offline for upgrades, they had one last chance. On March 20, 2025, they sent the command and waited. The reply, it worked. The thrusters fired up perfectly. This miracle save extended Voyager's life, ensuring it could keep sending data. The mission is a human story: persistence, creativity, and refusing to accept limits. The probes are lonely travelers, but they're connected to a passionate team on Earth. Thanks to this save, the epic of discovery continues. The Wall of Fire has serious implications for future exploration. While robotic probes can survive, humans are far more vulnerable. The danger isn't heat, but radiation. High-energy particles that would be lethal to astronauts. Any future starship would need advanced, heavy shielding, making interstellar travel even more challenging. The heliopause is now seen as a hazardous radiation belt, not just a gateway. We must learn to cross our own doorstep safely before dreaming of the stars. This may require new technologies like magnetic shields, but every age of exploration has faced barriers. The Wall of Fire is simply the next challenge. By studying it, we can engineer solutions and keep the dream of interstellar travel alive. The Voyager mission continues to unfold. With their lives extended, Voyager 1 and 2 push deeper into interstellar space, the first human-made objects to do so. Every day, they travel another 1,000,000 miles, venturing into the unknown. Their power is dwindling, and engineers must choose which instruments to keep running. The goal: keep them talking until at least 2030. When they fall silent, their journey will continue for millions of years, carrying the golden records as silent ambassadors. The Wall of Fire discovery has reshaped our understanding of the solar system's place in the universe. For every question Voyager answers, it raises more. We keep listening, straining to hear their whispers across the void. The journey of Voyager is our journey. The age of discovery is still alive.